drilled cavity problem is really a subtraction model. Today, we will identify the original solid, calculate exactly what was removed, verify the difference with a second method, and keep every dimension attached to the correct shape.
Here is the exact workbook prompt. A solid cylinder has radius 6 and height 15. A conical cavity with the same radius and height 9 is drilled along the cylinder's axis. We need the exact volume of metal that remains.
The choices are all multiples of pi: 432 pi, 378 pi, 216 pi, and 540 pi. So this is an exact volume question, not a decimal approximation.
Study the source figure before writing formulas. The black outer boundary is the full cylinder. The red region marks the coaxial cone drilled from the top face. Its base radius is 6, but its depth is only 9.
The cone does not extend through the entire 15-centimeter cylinder. Its vertex stops 9 centimeters below the top. That leaves ordinary metal beneath the cone, as well as metal around its sloping sides.
So our structural equation is full cylinder volume minus conical cavity volume. The phrase "no material is removed outside the cone" confirms that we subtract exactly one cone and nothing else.
For a cylinder, volume equals base area times height. Its circular base area is pi times radius squared, so the formula is pi r squared h. Here r is 6 and h is 15.
Substituting carefully gives pi times 6 squared times 15. 6 squared is 36, and 36 times 15 is 540. The full cylinder therefore has volume 540 pi cubic centimeters.
Squaring the radius is essential because a circle's area grows in 2 dimensions. A common mistake is to use 6 instead of 36, which would make every later volume far too small.
Now calculate the removed cone. A cone with a given circular base and perpendicular height has 1/3 the volume of the matching cylinder. Its formula is 1/3 pi r squared h.
For the cavity, the radius is still 6, but the cone height is 9, not 15. Substitution gives 1/3 times pi times 36 times 9. Dividing 9 by 3 first makes the arithmetic clean.
36 times 3 is 108, so the drilled cavity has volume 108 pi cubic centimeters. This is the amount removed, not the amount remaining.
Both volumes now have the same pi factor, so subtract their coefficients. 540 minus 108 equals 432. The remaining metal has volume 432 pi.
That matches choice A. The exact answer is 432 pi cubic centimeters. We keep pi because the question asks for an exact volume, and the choices are written in exact form.
Let us verify the scale before trusting the arithmetic. The cavity is a cone whose height 9 is 3/5 of the cylinder's height 15, while both solids share the same base area.
A cone adds the factor 1/3. Therefore, the cavity is 1/3 times 3/5, or 1/5, of the full cylinder's volume. 1/5 of 540 pi is 108 pi.
If 1/5 is removed, then 4/5 remains. 4/5 of 540 pi is 432 pi. This second method reaches the same answer without separately recomputing the cone.
We can also factor before multiplying. Both terms contain pi times 6 squared. The remaining volume equals pi times 36 times the quantity, 15 minus 1/3 of 9.
Inside the parentheses, 1/3 of 9 is 3, and 15 minus 3 is 12. Then 36 times 12 is 432, again leaving the exact factor pi.
The diagram agrees with that proportion. The red cavity occupies only the upper part and narrows to point, so removing just 1/5 of the cylinder is visually reasonable. A result near 0 would not be. The
units also confirm the operation. Radius squared contributes square centimeters, multiplying by height contributes another centimeter, and the result is cubic centimeters. Pi is a dimensionless constant.
Notice that exact does not mean incomplete. 432 pi is the precise value. Replacing pi with 3.14 would create an approximation the question did not request.
Now the main trap, treating the cavity as a cylinder. That would subtract pi times 6 squared times 9, or 324 pi, because it forgets the cone's 1/3 factor.
That incorrect subtraction would give 216 pi, which is choice C, so choice C is not random. It diagnoses a specific modeling error, removing a cylinder 3 times larger than the actual cone.
Choice D, 540 pi, is the full cylinder before drilling. Selecting it means the cavity was ignored. A remaining volume question must change the original total whenever material is actually removed.
Another error is assigning height 15 to the cone because 15 is visually prominent. Dimensions belong to named objects. 15 describes the cylinder, 9 describes the cavity, and 6 is their shared radius.
A quick estimate protects us too. 432 pi is about 1,357 cubic centimeters. It is positive and smaller than the full cylinder, about 1,696.
The exact ratio is even stronger than the decimal estimate. 432 divided by 540 equals 4/5, precisely the remaining fraction predicted by our shared base comparison.
Try a transfer example. A cylinder has radius 4 and height 12. A coaxial conical cavity with the same radius and height 6 is removed. What exact volume remains?
First, find the full cylinder. Pi times 4 squared times 12. 4 squared is 16, and 16 times 12 is 192, so the full volume is 192 pi.
The conical cavity is 1/3 times pi times 4 squared times 6. Dividing 6 by 3 gives 2, so the removed volume is 16 times 2 pi, or 32 pi.
Subtracting gives 192 pi minus 32 pi, which is 160 pi cubic units. That completes the same whole minus cavity method with new dimensions.
The ratio method verifies it. The cone height 6 is 1/2 the cylinder height 12. After the cone's 1/3 factor, the removed fraction is 1/6, so 5/6 remains.
This comparison method works only because the cone and cylinder share the same circular base radius and aligned height direction. If the radii differed, we would calculate both volumes separately before subtracting.
My mental picture is now simple. Begin with all the metal, outline exactly the region drilled away, and subtract that region's true shape. The word conical controls the 1/3 factor.
On test day, write the structure before the arithmetic. Then label each height, square the radius, keep the cones 1/3, subtract, and compare the result with the original volume.
One last look at the source diagram confirms every assignment. Radius 6 for both shapes, cylinder height 15, cone height 9, and a narrowing cavity that stops before the bottom face.
The full cylinder is 540 pi. The cavity is 108 pi. Their difference is 432 pi, and the ratio check shows that exactly 4/5 of the original metal remains.
So the correct choice is a 432 pi cubic centimeters. The decisive ideas were modeling remaining volume as subtraction and remembering that a cone is 1/3 of the matching cylinder.
That is the complete lesson. Read the geometry, attach each dimension to the right solid, subtract the true cavity volume, and verify the scale. With that structure, composite volume questions become controlled and dependable.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.